This is the installation course for Panasonic 9000 through 24,000 single zone models and also multi-zone models. Please note that neither product overview or applications is covered in this training. Before unboxing the equipment, make sure that it is a match set and it is what you need for your specific application. For instance, make sure that the system is a heat pump if you need heat. If you need low ambient cooling, make sure the system you have purchased will provide cooling in these conditions. Make sure that the indoor and outdoor models are a match set or they may not even run. The indoor unit will give an error code if the system is mismatched. All Panasonic systems use inverter compressors. What is an inverter system? Basically, it is a system with a variable speed compressor and multi or variable speed fan and blower motors. This, along with multiple thymistors, an electronic expansion valve, and intelligent circuitry, means Panasonic mini splits are able to provide excellent comfort and energy efficiency. The compressor capacities will vary from approximately 20 to slightly over 100% of its rated capacity. All this means you get the capacity you need, not more or less. Did you know Panasonic is the #1 compressor manufacturer in the world? Or that as of 2014, Panasonic has been the #1 selling mini split manufacturer in Japan for 8 consecutive years. All Panasonic systems use 410A refrigerant and require a few specialized tools. A flaring tool for a 410A system will make a flare with a slightly wider shoulder to help seal better. A flaring tool with an eccentric lobe and a clutch will also help make a quality leak-free flare. The use of a torque wrench will ensure that connections are not over or under tightened. Too loose will cause leaks, and too tight will cause copper or brass connections to split, which will also cause leaks. All Panasonic units have 5/16" service port connections, so a set of 410A gauges and hoses with 5/16 connections is needed. A 1/4" male to 5/16" female adapter could also be used. If brazing is needed, then purging with nitrogen while brazing is required to prevent oxidation from building up inside of the copper and contaminating the system. Nitrogen is also needed for leak checking. Humidity in the air contains moisture, so a vacuum pump is needed to remove it and any other contaminants that are in the lines. To allow this moisture to boil, a vacuum of 500 microns must be attained. Microns can only be read with an electronic micron gauge. The right tools, attention to detail, and even customer education on things like operation of the remote will all lead to a quality job. A quality installation means minimal callbacks and a happy customer who will tell their friends and family, which hopefully leads to more business. At the end of this course, there's a list of things that can be checked before leaving that includes items such as power, piping, wiring, drain lines, and how to verify system performance. Shown is the basic system layout for a wall-mounted single-zone mini-split. Other styles and multi-zone models are very similar. Two separately insulated refrigerant lines connect each indoor unit to the outdoor unit. Each indoor unit has a condensate drain, and a PVC adapter is included that will allow this drain to connect to a 3/4" PVC pipe. If the adapter is lost, one made by RectorSeal is available from many distributors. The RectorSeal part number is 83020. Most units come with a standard wireless remote, but a wired one is available, except for the 4 models shown at the bottom of this slide. Don't forget items like a pad and drain line or line set covers. All units have clearances that vary from model to model. Please take them into account when selecting a location for installation. In this example, the outdoor unit has a minimum 4-inch intake clearance. The coil is on the intake side, so 4 inches may or may not be enough room to clean and service the unit. The circuit boards for most models are accessed by removing the top panel, so take this into consideration also. No matter what the factory minimum clearances are, please make sure that the unit can be cleaned and serviced and that the discharge air does not recirculate back through the intake. In some instances, a wind baffle is needed, and one is available from Panasonic, or it can be field supplied. Controlling wind through the coil and heating or low ambient cooling is very important in some installations. If multiple outdoor units are installed, the wind baffle can also be used to divert discharge air upward and keep it from blowing into another unit's intake. The Panasonic version is a 3-piece plexiglass design that can easily be cut to width if needed. The part number is WIND-B as in boy 1. Facing the intake side of the unit towards a wall or other obstacle will also help control blowing wind and reduce snow from collecting on the coil. In snowy areas, heat pump outdoor units should be elevated to keep snow from blocking airflow and to allow for proper draining during defrost. In some cases, heat tape or a pan heater may need to be installed in the bottom of the unit to keep defrost water from refreezing and to allow drainage from the unit. A drain connection can be attached at the bottom of the unit, but it is possible that the drain itself could freeze and clog if heat tape is not used. The coils themselves could defrost and be clear while there is still ice buildup in the pan. If air temperatures are below freezing, this ice buildup could grow until it strikes the fan. Also take cleaning and service into consideration when selecting a location for the indoor unit. In this example, the minimum bottom clearance is 78 inches. If the unit is installed too low, hot or cold air can recirculate through the unit, causing it to think that it is satisfied. It can also cause the coil to become too hot or too cold and trigger the compressor to slow down to prevent freezing or high pressures. This can easily happen in installations like the knee wall of a sunroom. If the unit is installed too high, like on a cathedral ceiling wall, the warm air might not reach floor level. Air throws are available in the service manuals of each model. The wireless remotes use an infrared communication signal, and bright lights can weaken or interfere with the signal. In this example, removing the neon sign allowed the remote to control the unit properly. Two other potential problems with this example are a clogged condensate line could damage an expensive TV, or the heat rising from the TV could cause a continuous call for cooling. If it were in the heat mode, it might prematurely satisfy before the room has reached set point. The refrigerant and drain lines on the indoor unit can be routed through the left or right side or the left back or right back. This gives you several options when choosing a location for the indoor unit. If the indoor unit is mounted on an outside wall and the outdoor unit is directly on the other side, then exiting through the right and back of the unit would be easiest. This would also allow tightening and leak checking of the flare connections outside. If the line set will be ran in the wall, then routing into the back left side of the unit would probably be best. After hanging the unit on the wall plate bracket, you could tilt or move the bottom of the unit away from the wall, and the flare nuts could be tightened or leak checked. This example shows the line set coming into the left and back side. You can also see how the unit will hang on the top of the wall plate bracket and still allow access to the line connectors. Anchors and screws for the wall plate are supplied, but you can also use your own if needed. A 2 3/4 inch wall penetration is all that is needed to route the lines. If the wall plate is installed on an uneven wall, it could cause the unit to vibrate or become noisy. Be careful not to pinch the drain line and continue the slope or pitch so there's proper condensation drainage. There should also be no traps in the condensate drain lines. It is also possible to change the side that the drain hose connects into the drain pan. Another option is to run all the lines directly through the bottom of the unit by removing a plastic tab on the right or the left side. Never install dryers, vibration isolators, sight glasses, shut-off valves, or oil traps in the line set. If there is a service issue and the system needs to be cleaned, dryers can temporarily be used, and this will be talked about more in the service course. All units have piping length and elevation limitations. The installation instructions, which are included in the box, have these limits for your specific unit. All refrigerant lines must be insulated separately. In this example, a 12,000 BTU model requires a half-inch wide or suction line and a quarter-inch narrow or discharge line. The maximum elevation difference between the indoor and outdoor unit is 49 feet. The minimum piping length is 10 feet, and the maximum length is 66 feet. The unit comes charged for 25 feet of line set, and anything over that at 0.2 ounces per foot. The common question is, can I increase the diameter and length of the pipes beyond the factory recommendations? The short answer is no. Anytime you increase the lengths, you lose capacity and reduce oil flow or oil velocity if you increase the pipe diameters. In many cases, simply going up a half a ton in size will give you the extra length needed. Notice on this chart that going from a 12,000 to an 18,000 BT unit will allow an additional 34 feet of line set distance, over 50% longer. There are several multi-zone models, and the dual zone is shown in this example. It has the same limitations as a single zone, but with a few additional variables to consider. There's a maximum distance from the outdoor to one indoor, and in this case, 98 feet. If you add up the length of pipe from the outdoor unit to all indoor units, there is a maximum total, and in this example, it's 164 feet. There are maximum elevation differences between the indoor and the outdoor unit, and even just the indoor units themselves. In this example, the numbers are either 25 or 49 feet. The specific information for the unit you are installing will always be in the installation manual, which again is in the box. Staying within these limits will ensure proper performance and life of the system. Before making flares, always remember to slide the nut onto the pipe. It's very aggravating to make a nice flare and realize you forgot the nut. Make nice straight cuts and deburr the inside and the outside of the tubing. If you're not using the Panasonic supplied flare nuts, make sure that the ones you are using are heavy duty. Forged flare nuts are stronger than cast ones and less prone to cracking. Don't forget that both lines will sweat, so they need to be insulated individually. Companies like CPS make flaring tools, torque wrenches, gauges, and even complete tool kits specifically for 410A products. Shown are the torque requirements for different piping sizes. These specs will be in the installation instructions with your unit. A torque wrench is a requirement for a quality installation. It will help prevent callbacks and ongoing leak issues. Sealing compounds are not required for a properly made flare. With that being said, the Panasonic Tech Support Department has not got any negative customer feedback on products such as Nylog. All Panasonic coolant only and heat pump products have 5/16 service port connections. Your 410A service gauges require 5/16 hose connections, or you can use a readily available adapter like the one shown from Ritchie and JB. The Ritchie part number is 19173, or the Ritchie adapter with a ball valve is 93825. The JB adapter is part number QC-S5. Once your piping is completed, the system can be evacuated and leak checked. Pressurize the line set and the indoor unit to 400 psi with dry nitrogen and check the flare connections for bubbles by applying a soapy or leak detection solution. Ideally, we would like to have the system hold this pressure for 24 hours, but this is not usually practical. 30 minutes to an hour should be minimum before vacuuming. Next, release the nitrogen pressure and connect your vacuum gauge and pump. Pull the system down to 500 microns. If 500 microns cannot be attained, there is either a leak or contamination in the lines. If no leaks are found, you can usually pressurize the system with nitrogen and vacuum it several times to clean it out. When 500 microns is reached, close off your gauges and turn the pump off. The system should be held in this vacuum for a minimum of 30 minutes to an hour. Continue with the rest of the installation while vacuuming and pressure testing. All indoor units get their power from the outdoor unit. Run the power supply from the disconnect to L1, L2 inside of the condenser. The ground should run back to the panel and is highly recommended to drive in an additional earth ground also. Although not required, we have received positive feedback from customers using surge protectors. People with unreliable power supplies or in storm-prone areas have used them with great success to prevent damage to their equipment. And at less than $50, it is cheap insurance. Depending on the model, from the outdoor unit run 14-3 or 16-3 wire with a ground to the indoor unit. It should be stranded wire and the ground should be wrapped also. We do not require a disconnect at the indoor unit, but if the local code requires it, terminals 1 and 2 are the power supply. Terminal 3 is the controls communication wire. With multi-zone systems, you run the same 3 wire with the ground from the outdoor unit to each indoor unit. Again, there is only one power supply circuit ran to the condenser, and it also powers each indoor unit. The interconnecting wiring is simple, but mistakes can easily be made. The wires must be landed from terminal 1 outside to terminal 1 inside, then 2 to 2, 3 to 3, and ground to ground. Wired wrong, there will be communication errors and no heating or cooling. If the wires and piping on a multi-zone are mixed and ran to different indoor units, there could be over and underheating and cooling conditions. This is because the crossed indoor units will be controlling each other's set point and expansion valves. This picture shows only one conduit connected to the outdoor unit. This means that the power supply to the outdoor and the interconnecting wires to the indoor unit share the same conduit. These should always be ran separately, or it could lead to communication problems and error codes. This system might run perfectly for days or weeks between issues, and it could lead to an ongoing problem job. In this picture, a multi-zone unit has a separate conduit for the power supply, but the 2 indoor units share a conduit for the interconnecting wires. Each of the interconnecting wires should have its own conduit to keep noise or induced voltage from causing communication and controls issues. Stranded wire should also be used. L1 and L2 at the outdoor unit is power from the disconnect box. Terminals 1 and 2 at the outdoor unit is your power supply to the indoor unit and must be landed at terminals 1 and 2 of the indoor unit. Terminal 1 and 2 at the indoor unit should read the same voltage as terminal 1 and 2 at the outdoor unit. Remember, these wires are polarity sensitive and can't be crossed. Running the interconnecting wires close to high voltage or close to ballast or transformers can cause communication errors. If you're getting a communication error, the way you could check is go to the outdoor unit and remove the wire at terminal 3. Take a DC voltage reading between terminal 3 and terminal 2. Write it on a piece of paper and reconnect the wire and go to the indoor unit. At the indoor unit, remove the wire on terminal 3. Take a DC voltage reading between the wire and terminal 2 and write it down on a piece of paper. The voltage reading at the indoor unit and the outdoor unit should be very close to each other. If it is high or low, this is an indication that you're having communication problems. If a condensation pump or a drain overflow switch is used, the safety switch can break or open the number 3 interconnecting wire. This will cause a communication error code and the system will shut down until the problem is resolved. Most units come standard with a wireless remote controller. This remote is also used for self-diagnostics when there is a problem. A sticker inside the cover of the indoor unit explains the procedure and gives a list of error codes, and we'll go over this in more detail in the service video. Remember, the remotes use an infrared control signal and bright lights can interfere or block the signal. If there is a power failure, the units will automatically start themselves when power is restored and go to their last setting. The remote is not required for auto restart. If there are multiple indoor units, it is possible to readdress the remote so they can only control one indoor unit. Up to 4 addresses can be used. The exact procedure is in the manual that comes with the indoor unit. As you can see in the pictures, the remote case must be split open to access jumpers that are cut. Our experience has been that many times readdress remotes are lost, misplaced, or mixed up with other remotes. If a readdress remote is used to control another indoor unit, the customer may think that the unit is broke, and this can be difficult to troubleshoot. In some cases, one day, the customer will use the correct remote, and the next day they'll use the wrong one, so they think the unit is experiencing intermittent problems. Another solution would be to use only one remote and put the others away as spares. Once the units have been turned on and set the way you want them, the remote does not have to be there. Using one remote can create less confusion, especially if the units are installed in rental or commercial property, where there are multiple people and a turnover of personnel. An optional wired remote control is also available. It comes with 32 feet of cable with connectors on each end. This cable can also be extended to as long as 650 feet. Be careful not to run the wire next to high voltage or light ballast. This remote is also capable of self-diagnostics. Before starting the equipment and completing the job, go over your installation. Verify that the line set was pressure checked and vacuumed, that both lines are separately insulated and there are no kinks in them. Verify the line lengths and elevations are within the limits of the equipment installed. Remember, there should be no dryers or sight glasses in the lines. Verify that the wiring and the voltage is correct. Make sure that both power supply legs are hot. Sometimes lights will come on dimly and the indoor fans will run slowly with just one leg of power. Verify the condensation line is ran and that it does not have a P-trap in it. If there is a condensate pump and the safety is used, make sure it's breaking the number 3 wire. Pour water into the drain pan to verify operation of the pump and proper drainage. If the unit needs additional refrigerant, verify that it was properly calculated and added. Make sure that all packing material is removed. Verify the remotes are working. The indoor units will beep when they receive a command from the remote. You can test this by pushing any button on the remote. If everything checks OK, the unit can be started. In the cooling mode, set the temperature as low as it will go and let the system run for about 15 minutes. Measure the running amps and compare it to what is on the data sticker. Check the superheat at the outdoor unit. Measure the temperature of the suction line within a few inches of the flare connection and write it down. Take a pressure reading at the suction line service valve and convert it to temperature by using the conversion chart on your service gauges. Subtract the converted temperature from the temperature on your thermometer. This is your superheat. If the compressor is ramped up, the unit is properly charged, and there are no airflow or line set restrictions, the superheat should be around 0 to 5 degrees Fahrenheit. The air temperature drop, known as delta T, through the indoor coil should be at least 20 degrees. If the humidity in the room is low, the delta T could be as high as 35 degrees. Remember to complete a good installation and minimize callbacks. The end user should be shown how to use the remote and operate the unit.